Hello. In this video, I'm going to show how to derive the formula for the integral of secant and for the integral of cosecant. So we'll start right away with writing the integral of secant of x dx. Now, of course, you can change secant to the integral of 1 over cosine of x dx. But that doesn't really do anything for us, and it leaves us really stuck, nothing to do. What we want to do is try to write this as something that we can recognize. There's a real trick for this one. It may not be something you'd think of right away, but if you take secant of x and you multiply it by secant of x plus tangent of x over secant of x plus tangent of x, you'll get this. It's interesting to see. You get secant squared of x plus secant x tangent x over secant of x plus tangent of x. Now, it's not really obvious right away, but if you look at this, the derivative of secant of x is secant of x tangent of x, and the derivative of tangent of x is secant squared of x. So in reality, we're in the form of du over u. I'll show you. Let's pick another color. Let u equal, I'm going to write it as tangent of x plus secant of x. So then du would be, again, derivative of tangent is secant squared of x. And the derivative of secant is secant of x tangent of x. All right, so you can see right here from this that the derivative of oops, include the du in with it. So that would be du, where the denominator, let's go ahead and circle the denominator down here. We'll use the same color. The denominator is equal to u. So this is our old friend, the natural log, and our answer ends up being the integral of ln, we'll back that off. Answer ends up being ln of the absolute value of u, and u is secant of x plus tangent of x, then plus c. So that ends up being the integral of secant of x. So our initial idea of writing this as 1 over cosine led to nothing, so we'll get rid of that. But turns out that the integral is indeed ln of secant of x plus tangent of x. All right, we can do the same thing really for cosecant of x. So if we write the integral of cosecant of x dx, and go ahead and take that cosecant, and we want to multiply it by cosecant of x plus cotangent of x. Okay, it's really the same thing as we did last time. So over cosecant of x plus tangent of x dx. All right, when we distribute that out, we end up with cosecant squared x plus cosecant x cotangent x. The denominator stays the same. Stays as cosecant of x plus cotangent of x. And I notice up here I wrote tangent of x where I meant cotangent of x. Right, this has to be something equal to 1. So let's fix that. That has to be cotangent of x. Right, I should have noticed that this has to be the same thing over itself here, so it's equal to 1. All right, now we can use u substitution. If we let u equal cosecant of x plus cotangent of x, then du is going to be equal to, derivative of cosecant is negative cosecant x cotangent of x. The derivative of cotangent of x is negative cosecant squared of x. almost off the screen here. So we actually need to multiply the inside by -1. All right, so we're going to multiply that by -1. That'll make that negative cosecant squared, and that negative cosecant x cotangent x. So I need a -1 on the outside. Now we're actually in the right form. We're in the form of du over u. Again, this part with the -1 matches our du. Right? Matches that du right there. This part right here matches the u. So that's u. So we're in the form du over u. That's the integral. That integral is equal to the natural log of the absolute value of u. So negative, brought from above, ln of absolute value of u, which is cosecant of x plus cotangent of x plus c.